Hey, welcome to Wally Hill's Garage. Today we're disassembling a Dewalt DCD995. We're replacing the chuck because the Cobalt teeth in the chuck destroy the bits. It bites into them. So I just wanted a normal chuck without Cobalt bits in the holding fingers. So to remove it, you have to take away the 4 screws in the front of the drill and then the screws that surround the drill. You'll also have to remove the sticker, I think the front and the back of the drill. Either you cut it or you just peel it up. I peeled it up, so I didn't have to cut it. You have to watch out for this button that you see right here in order to make sure that it doesn't get caught in the wires or it doesn't get caught when you remove it. I tended to take the right side half of the clamshell. You can see the sticker is fully intact in the back there. It says brushless, I think, so that sticker is. You can buy new ones, I think, from Dewalt. But once that's removed, you want to get that front portion with the chuck attached off, the piece that says XR and the selector. And that can be removed from the motor in the back and that gear shift switch at the very top. You gotta kind of pull that out, and then there's a spring there that could pop out. You'll see us put it back in later on. Just be very careful you don't lose that, because you need it to make that clicking sound when you move that switch back and forth. With that, you'll see the very front there is, I think it's a friction fit pin. So make sure you kind of slightly pry that once you get all the screws out in order to get the halves to come apart. And once you have that, you should be able to then free the front part of the metal gear case with the chuck. And those are the amount of screws. I use a magnetic tray to make sure I don't lose them. I think there's 2 different sets. There's 4 in the front, which are longer, and the other ones I think are all the same. So let's go to the next step. You can get the chuck out. It's very difficult. You have to disassemble the motor to this point, and we'll show you how you get to this point. And then you bring in the gear puller, and you put it in, and there's an edge here you can catch with this. So it'll catch here. It's a metal piece, and then there's a point at the end of your gear puller, and there's a point. You can see it right there. So it fits in so it doesn't wobble off the shaft. And then when you get it in there, you can then turn this, and it'll just yank this thing off the bearings. If you look at, there's a needle bearing, and then there's a ball bearing at the front here. And then you can get access to those 3 screws that allows you to remove this. There's needle bearings in there, if you can see that. See those little long horizontal poles. And then here, there's a ball bearing. And then here's the 3 screws that allow you to access this piece here to remove it to service this clutch where this piece of wire is going into. But yeah, this is all metal. So, okay. So with that taken off, you got this. And then there's a screw that's left-hand thread that you have to undo. It's a T20, it looks like, T20 Torx. And then you put a Allen key in here. And what I like to do is, there's a special tool that fits right over this oval. I think the diameter is 8.81 millimeters, and then the width is 6.997 millimeters in the flats. Since I don't have that tool and I can't figure out how to buy that tool, and even the suspension tools that Snap-on has, which have these oval cuts, they're the wrong size. It's not going to work. I also tried using one of these sockets with the pins in it. That's no good. It's not going to grab that. That's actually hardened. So if you notice, to be totally frank, I've kind of damaged my crescent wrench here because I was going this way to hold it, and then using a pair of these kunai picks to grab the unit here and turn it without removing the shell, and that's not a good idea. So you want to do this, put it in, and then you can get a full solid purchase on those flats, and then you turn and you start seeing some deflection here. At some point you hear it go crack, and then it'll turn, and I just did that, and which is now allows us to remove the shaft of the DCD995, right? And it's right-hand thread here, because if you think about it, right, most drills turn this way, and so you want it to tighten this way and not the other way. So the thread for the screw is left-hand thread, but the actual chuck is right-hand thread. Now, the reason I'm replacing this is the carbide inserts on the points in the chuck are destroying all of my drill bits because they're harder, the drill bits, because of all the
carbide, and they bite in and leave these 2 lines. I've ground out the lines, but I think now the chuck isn't perfectly centered. I took a diamond bit, put it in, and then basically wore away those grooves. So that you want a kind of a flat, maybe like a single bump to grab onto your drill bits. But unfortunately, it's destroyed my Forester bits and a bunch of other bits. So I'm going to replace the chuck with one that doesn't have carbide inserts. But this is the hammer drill that Dewalt has, the DCD995. So the DCD995, yes, you can get the chuck off. It's very difficult unless you disassemble it and get this onto those flats. So if you want, this is how you put the shaft back in. We take our gear puller and we attach it basically to the metal shell, and then the pointy tip of the gear puller goes in that hole, and it'll push that shaft all the way home. So I wouldn't pound it in because you'll damage the threads. If you use a metal hammer, if you use a rubber hammer, I think it damages the rubber hammer because that's harder than the rubber hammer. This is actually hardened steel, this shaft, so it's perfectly concentric, and that's why it destroyed my crescent wrench. If you look at the crescent wrench here, obviously the damage, right, there and there. And that's because I had it like this. We had just the tip grabbing the flats, and then we grabbed it here with the kunai picks, the large kunai picks, and then we tried to rotate it. That's not going to work. You need to have a good purchase on those flats. So get in there. Now there is a tool. I don't know how to get it, but I measured with a vernier caliper. The flats are, as we said, I think 6.997 millimeters. And then the radius, if that was a full circle from there to there, is 8.81 millimeters. And then the sockets, I think Snap-on sells 3 different kinds of sockets for different kinds of suspensions. For cars, there's a hole in that socket that's an oval, but the flats and then the radiuses of the hole will not match this. So unfortunately, it doesn't really work. And as you see, we tried the gator bit with all the pins. Well, that doesn't grab at all, right? That's not going to give enough torque. And then this pin here is induction hardened, it looks like, and it kind of screwed up. It's harder than obviously my crescent wrench. So by taking it out and grabbing the whole thing with the full flats and then twisting it, that was quite a lot of work. And then you hear that crack, and then it unscrewed. So yeah, it's unscrewable. It's really tight because I think they tested it with the hammer action. So it basically, it's a right-hand thread. So as it turns, it gets tighter and tighter. The screw that retains it is a left-hand thread, right? So I guess in reverse, the screw catches it, but in the main drive, which is right-hand spin, a right-hand thread will cause it to come together really tightly. So anyway, that's how you get it off. Pull it with the gear pull. Do not hit it with a hammer. Some people have it on a block of wood, I guess, and they tell you to tap that out. Well, clearly, as you see, the little hole there fits the tip of a gear pull. So the gear pull the other way will push the pin out if you want to do that, and you'll have to in order to get the setup where you can use this to basically crank that off. Why is it so tight? Do not know. How do they do it at the Dewalt Center? There's a tool that slips this way onto this hardened bit, and then you put a really massive ratchet here, and then you do the same thing. Put a Allen key or something in there, and then crank it to break it off. But they would have to disassemble at least to this stage in order to get it off, because you couldn't do it here. You might damage the gears forcing it around. I don't think that is going to hold the level of force you need to break the threads. Now, the interesting thing, if you look at the threads, which are right here, there's no Loctite on that. It's just purely mechanical connection. And maybe what we call, I think it's Van der Waals forces between the two pieces of metal meshing together, that they're kind of binding. I think that's what's actually happening there. So you need a lot of force to break that free. So anyway, the DCD995, it's the chuck is removable. I'm removing it because, again, if you look at the tips, if you can see them, hold on. If you see them here, they have inserts. These are made in Germany, if you can see that right there. It says made in Germany. I don't know if you can see that. It says German right there. These are Rome chucks, most likely. And I think Dewalt selected them because with a hammer action, you don't want the bits slipping. But for hammer action, you'll typically use hardened bits, right? So these carbide bits will definitely grab, but they have lines in them. So the normal bits that you use would have scoring. As you crank this tight, it causes the lines to be cut into the metal and causes like little bits of spall, and therefore it's not concentric. You grab that spall, so you have to file every bit after you use it. So this is only good for drilling into concrete. Since I don't drill into concrete quite a lot, I'm going to remove this chuck and put in a much lower price chuck that does not have carbide bits in the jaws, and therefore it won't destroy my drill bits. So anyway, that's how you get this thing off. It's been bothering me for a long time. I've destroyed a lot of drill bits with this, and finally I got around to I'm going to fix this problem. So there you go. That's how you do it. And this is the way to push, again, the shaft back in to the needle bearings and the main bearing. But once you have the chuck removed, then you have access actually to these 3 screws here to take off this front piece to get into the electronics that they have for the clutch. This is not mechanical anymore. It's just basically telling a circuit in the back when to release, because it's a brushless motor, which is using a Hall effect sensor to note where the rotation of the shaft is. But this whole thing here, I think these used to be mechanical. These are no longer mechanical. It's a circuit board in there. So this piece is separate from this piece. These are not connected. So you can take it off by those 3 screws. But you couldn't get to those screws if you couldn't get the chuck off, right? You'd have to punch the chuck with the shaft out to get to them, which is what I did last time. But here, with the chuck off, I'm going to put, obviously, nickel or copper anti-seize onto those threads to prevent that from ever happening again where I can't get this thing off. And then that allows us access. So anyway, you need a few tools, but you should be able to get to it. And that's how you take apart a DCD995. So let's show how we're going to put it all back together and make sure it works. It's a great drill, by the way, very, very powerful. So there's the unit with the shaft pressed back in and the chuck removed. This is the actual gears inside. Notice how the plate, I basically, when I took it out, I took this and dropped it like this because there's a bunch of little bearings in here and needles that you're gonna have to reset. Hopefully I'll be able to get it back in with one unit. I've taken it out before, and then this piece and that piece kind of get separated, and then gotta put it all back together. So I just kind of dropped there's one piece. And then when that goes back into the case, you have to put the selector here, and it also comes with this little tiny, I don't know if you can see that thing right there. The thing with the spring and little cap, that goes underneath this, and that then clicks as it slides up and down here. So we'll have to put that back. That springs out, so be very careful when you take it out. So let's try to put this back into the case, and then put that little spring back into that and slip it into the case here. You kind of slide it kind of at an angle to get it into the teeth there. And then you plug in that plug over here, which is what plugs into this electronic clutch selector here. Okay, so let's go try that. We might want to put this disc in first because it has to fit, I think, within that 1/3 of the unit. And sorry, those are the bearings, if you can see them there. This plate, maybe we should just put it in. This plate keeps these needle bearings here. You can see them from falling out when we put it in. So maybe we'll just arrange this like this, and then again put it up straight with this like this. This bump is the top, so therefore you probably want to line up with this here. So let's try. So we're gonna use some of this Teflon grease, silicone grease. It's really thick, very viscous. And the reason why you want to do that is when we're trying to assemble this thing. If we look at this gear casing here, if you see those little pins here, right? But these 5 pins form the lock, right? So when you turn it, these pins kind of jam against the outside case. and then make it so it doesn't move. But you have to kind of flip this thing upside down and put it in, but these pins will fall out. So if you use this stuff here, because it's super viscous, what we're going to do is we're going to use this goo here to stick these pins in so they don't move. Right? Well, that came out. So by doing that, we should be able to then invert it, be able to put these in. Okay, so then we can then flip this over and then drop it into that gear case over there. So we turn it over, those pins don't fall out. Okay, so here's the case. You see here, we have to turn this thing over to drop it in. Otherwise, that other thing will fall out. As you can see, it just went in. But yeah, you need that glue there to help out. All right. Next thing we try to drop in is this assembly here. Okay, that went in. And then this ring. That went in pretty nicely. That's what it looks like. And that little hole up here is where that little spring, this little spring goes. And that gives you that clicking sensation. Okay, so I put it back into the drill. This is the gear cap. Make sure that this is flush and it goes in really easily. If it doesn't, it means it's a shim or something that's problematic down here. I had a shim that was slightly out of place and this didn't quite close, so don't force it. It means something's not going right there. So there's two Torx 10 screws here. To tighten them up like this, and that'll hold your gears in place, and then put the motor back in. And there's the DCD995 Type 1 with its chuck removed, and it still works. All the speeds work. Reverse works. So it's waiting on its new chuck. It's an excellent drill, but yeah, getting that chuck off is pretty tight. Now, if you look at this, I don't know if you can get really close here and take a look, but you see there's no Loctite on those screws. It's just really high torque that they use to put it on. And then there's that flat machine surface down there, so that shiny surface, the shoulder. I think that, plus those threads, and a lot of torque, the Van der Waals were spinning those two materials were just kind of molecularly holding it together. You had to break that, and that took a lot of effort. I doubt you could have broken it with a Allen wrench in here and the drill itself. You probably would have broken something. So you'd had to take it out. This shaft is actually, it looks like it's induction hardened because it was destroying my crescent wrench, as you saw. And it's not touched at all. So this has to be hardened. It's hardened, perfectly machined and straightened so that it spins true. If you notice, see that? It spins absolutely true. So yeah, that's going to be very difficult to get off without getting the full purchase on the flats, and you have to do that from inside. So it's take off these screws, and you saw how the gear case came out and some of the stuff we had to do here. But there you go, the DCD995. We're putting on a non-cobalt tip chuck so it doesn't destroy all of our soft shafts on our normal bits. I'm rarely drilling anything into concrete, so I don't need the hardened concrete bits. So for this to hammer, and so therefore for the normal bits, you really don't want that chuck. It's a Rome chuck, I think, from Germany. It's a really high quality chuck, concentric, but it just destroys all of your drill bits and your shanks on your drill bits. So, okay, it's a great drill. I definitely think you should try this to make sure you get maximum value out of it.